In this video, I am going to explain next classification of the hybridization or next types of hybridization. So, in the previous video, you have seen sp3 and sp2, two types. Now, here the third is sp hybridization. sp hybridization, and sp hybridization, it is called as linear hybridization. It is called as linear hybridization. Linear hybridization in the sense the molecules have linear geometry, and as for the point here there is one s and one p orbital, one s and one and one makes two, and they form two sp hybrid orbitals. There is formation of two sp hybrid orbitals. Now we will see example. Actually, here the alkynes like C2S2, it undergoes sp hybridization. So again the same point, you write down the electronic configuration of carbon, and here in excited state 1s2, 1s2, 2s1, 2px1, 2py1 and 2pz1. So here this is the configuration in the excited state configuration it is there. Now here out of this is fully filled. So here they undergo hybridization, but these two they undergo hybridization, and these two they left unhybridized, and they undergo hybridization. Now see here how it happens. In actually what happens, if you draw here there is this is our 2p, it is here the 2p, first we have the 2s1, this one, then here we have the 2p x1. So they will only undergo hybridization. Plus we have to mention these two also. We don't have to scale. It must be mentioned or written. Plus here 2p y1 and this 2p z1. So they will not be involved in hybridization. So this is very important point about hybridization, that they will remain as it is. So two are participating, two will form, and here there will be here 50% character and 50% character. So they will have the equal contribution, and so the newly formed orbital will have the neither complete S nor complete P, but 50-50%. So see how there will be formation of the orbitals like this. See, it will have like this. There will be dominance, and the lobes will be here. It is having the impression of S as well as P. What about these two? They will remain as it is. They will remain as it is here. So this is for the one carbon. Similarly, for the other carbon, here we will draw here. And the construction of lobes, here there is other one, and here there is other one. Now these two, this will overlap. Again this will overlap, this will overlap, and here this will overlap. So here there will be the here there will be the pi bond, here there will be pi bond, here there will be sigma bond, and here there will be hydrogen sigma, and this hydrogen sigma. So see here, very important point, that pi is equal to how much? 1 plus 1 is equal to 2. Sigma is equal to 1, 1, 1. So sigma is equal to 3. So this is there about the sp hybridization. Now other point you have to keep in mind, children, that see the newly formed, this is one case, one carbon, this other carbon actually it is C2H2. And so here if we draw, so there will be triple bonding between the two. See here, actually this is one lobe, this is other lobe, this is one lobe, this is other lobe. There are two lobes, two sides here. So if we draw here, I'm just again drawing for your better explanation so that you can understand more clearly here. This is one carbon, here there will be the other, here there will be, and there will be here, like this. So here sigma, here there is one hydrogen sigma, here there will be the one hydrogen sigma. Now see, this will overlap. This vertical will overlap with vertical. There is the proper alignment. Vertical will overlap. It is sidewise overlapping. Now this oblique will overlap with oblique. This vertical will overlap with this, and this will overlap with this. So here there is one pi, there is other pi, and these are not four bonds. Actually, there are two lobes. So if we draw here, so carbon triple bond, and here there will be one, and here there will be one. So this is pi, this is pi, center one is sigma, this is sigma, and this is sigma. So this is how there is the formation of sp hybridization. It is in case of acetylene, and so this is about the sp or linear hybridization. Similarly in case of DsP2. Now just I am going to explain briefly about the port DsP2. So DsP2 it involves one D, and there is one S, and there is 2P. And so here 1, 2, and 2, 4. So there is summation of 4 DsP2 hybrid orbitals. 4 DsP2 hybrid orbitals, and here it will have a square planar geometry. The molecules will have a square planar geometry. A square planar geometry. If you take here, so there will be an atom M left in the center, and so here there will be other, here there will be other, and so here like this, the let atom be A here, so A here, and this. So they will have this kind of square planar geometry, and so just brief introduction, like if you take the nickel here, Cl4 2 minus, so this is it is in class 12. Now coming to fifth one, sp3 d2. Here 1s plus 3p, and here there will be 2d. So 1 plus 3, 4, and 2, 6. So this summation of 6 sp3 d2 hybrid orbital. There is summation of 6 sp3 d2 hybrid orbitals, like in case of SF. Now coming to then, so there is summation of SF6 6sp2. Now 6 point, here the 6 they are found, and there is 6 hybrid orbitals. There are 5 also, like in case of PCl5, and there is only sp3d, here sp3d. So sp3d, it has 1s plus 3p and plus 1d. So there is solution of 5 sp3d orbitals. 5 sp3d orbitals are formed. Now here, in all the molecules, I am talking to a general point, all the molecules having this type of hybridization. So here the molecules will have trigonal bipyramidal geometry. This is a very important point to note. All the molecules which undergo sp3 hybridization will have trigonal bipyramidal geometry. Now coming to here, this sp3d2, and here it will have the octahedral. We can identify the molecules, and so this is there how we can explain the hybridization.